We're looking at the automotive electronics driving forces. So it's at the bottom in black are the technology push factors that are advanced electronic system. IC technology has been by far the most important factor, and this is not ending anytime soon. Battery EVs and autonomous vehicles are emerging rapidly and will dramatically impact the auto and the transportation industry. On the left side in blue, summarize the software technology and platforms. The software-defined car, in essence. Domain ECUs are becoming a key factor in expanding the software-defined car. And connected car apps have been on a growth path, but it's becoming a high-tech domain as the smartphone apps are taking over the infotainment system. OTA and cybersecurity have become required capability, and they're going to be really, really important as we go forward. The auto OEMs have ambitions to develop an increasing part of their software in-house. So far, this has been pretty hard, and I'm expecting that to continue. The cloud and the SaaS platforms are impacting auto software at multiple stages, with Amazon, AWS, and Microsoft Azure gaining new customers in the auto industry. The right side in red shows the impact from business model disruption. Mobility as a service is emerging slowly, with Go Robotaxi, goods delivery, both local and long haul, and fixed route autonomous vehicles. The SaaS business model has increased software opportunity in many industries, and I'll talk more about that later. Pay-per-use is similar to SaaS, but it needs some listed separately because it tends to increase the valuation of companies that has that. The top section in green shows the customer pull factors, and much of that is from regulation. Price and cost are always important, especially playing out between battery EVs and combustion engine, purchase price, operational, and maintenance cost. And safety is a growing in importance with the NCAP and IHS ratings with recalls as a constant factor. So let's look at what the software-defined car means. It's an increasing share of car features are implemented via software and the required hardware. Two distinct categories: embedded software clients that are in the car, and then the software as a service and cloud software to provide services. And so next I'll talk to each of those separately. Car system feature. Every ECU has embedded software platforms, multiple of them usually. It may also have connected software services such as OTA and cybersecurity. If you look at the connected car and infotainment, the clients is the OTA and cybersecurity becoming the most important. OS and middleware software platforms are clients. Then speech recognition, HMI, navigation, maps. More clients are in the music and other content. And extracting data and receiving content are becoming important. In the SaaS and clouds area, car-centric and driver-centric telematics context was the first cloud application, and then OTA and cybersecurity, and I keep emphasizing that that's becoming so important. If you look at the ADAS and automotive area, the clients, you still have to have operating system and middleware. Many ADAS applications are appearing. In the clients, the inference type AI-based software platform for sensor-based, both for vision and software driving are appearing. And then more cloud is the maps and road information, sensor data, AI training and analytics, and AV simulation or virtual driving platforms are there. For driving control, it tends to be AutoSAR as the main platform. Driving ECU's application. If you look at AutoSAR, 35% of cars sold in use on worldwide is AutoSAR, and 50% plus in Europe. OTA and cybersecurity is again starting to get built into AutoSAR. Remote diagnostics and prognostic and analytics and training. So now let's look at the content data monetization. And Otonomo is really the leading independent company there, and they just filed to go public. And so there's a lot of data available on them. If you see the top of the figure, it shows the auto OEMs that already provide data to Otonomo. It's quite impressive. BMW, Daimler, GM, Ford, and a total of 16 OEMs. As of February, 40 million plus vehicles provide data, and it's about 4.3 billion data points per day, including about 150 parameters from the car. A typical data point consists of 5 parameters with a timestamp. Common example is longitude, latitude, speed, heading, and then ignition status. So if I assume that one data point is 12 bytes, then on a daily basis, Otonomo gets about 400 billion bits in a total. The software platform that they have is in red. It's raw data coming in, and that requires considerable analysis and cleaning before it's legal data ready for sale. Privacy laws, government and industry restriction must be followed. The black boxes on the bottom it shows the data customer segments that they have. And they have had about 140 data customers as of February. So they also gave the value of data. So let me give you that. It's not on the slide. Fleet operators pay about $25 per vehicle per year. Insurance company for UBI, they're $15 per vehicle per year. Car dealership, similar, $15 per year. If you look at the financial industry, now it's per million data points. They pay about $30, so not very much. Smart cities also pay per million data points, and it's about $40 to $80. And transportation operators, they pay up to $100 per million data points. So let's look at how connected cars and autonomous vehicle go together. It has this one. It's an overview showing when data goes to and from AVs by use cases, and I'm using color codes, as you can see there. The timeline on the bottom gives an estimate of when AV use cases see volume deployment. And the two and the from blocks, they really overlap, but as you can see, I didn't have space for that on that. Note that personal AVs come much later than other AV use cases. The from data blocks show data that are similar, with operational data being the most constant. These are safety tracking and then the cargo status if they're using that. The two blocks show the OTA and cybersecurity updates are crucial, including functional updates. The two black boxes on the right have questions on what other data autonomous vehicles may use. Teleoperation, for instance, immediate crash data, AV to V2X synergy, and redundant comm links. Other question, timing of AV safety standards, government regulation, and will there ever be a driver's license for autonomous vehicles? So let's talk about AI, because it's continues to be important, especially in autonomous vehicle. And I'm using a slide that I saw from IBM as the basis for this. And so they have three categories. Narrow AI is defined by deep learning, single task, and single domain. A single domain requires a large amount of labeled training data, and the label has to be done by humans as a rule. Narrow AI started really in 1950s, but hardware was too slow to do much. There was a brief excitement in the PC-based expert system in the late 1980s, but around 2015, the GPU processor kick-started our current growth phase. We are still in the narrow AI phase. The broad AI is the next phase. It is expected to be disruptive and pervasive. IBM calls it neurosymbolic AI. It's capable of multitasking, multi-domain, and multimodal operation. It's more trusted AI and capable of learning with much less data. Hardware speed up potential, AI chips, AI accelerators, reduced precision, and even some analog hardware. This phase is just barely getting started in terms of investment. The third category is the general AI, which is much further down the road. And IBM calls that true neuro AI. Cross-domain learning and reasoning, broad autonomy with moral reasoning. Hardware speed up, maybe on the cloud, you might have quantum computers. At the chip level, you're going to have 3D system on chips, chiplets, and various other technology. When? Well, 2030, 2050, and some people even says never. So this is a slide on business model disruption. The context there is that it's how the software impact on the whole car. So the top 4 blocks show what I call 4 phases: create, make, market, and use. The create, make, market, I learned at Texas Instrument, they used it, and then I add the use case because cars are used 10 to 15 years typically. So the create software is most expensive phase due to the testing, the finding and fixing all the software bugs. Roughly today, it's probably $30 per lines of code to develop new software. The make software, really, there's no bill of material cost, some royalty cost, but the make phase is really loading software into the hardware, and version tracking is required. The market software, now you're talking about feature, really sells automotives, and so feature can be software, or they are software defined in most cases. And usability is a top concern. Cloud platforms have important in terms of car ratings of the very software. And then the use software case, OTA for bug fixing, cybersecurity is required. SaaS and data as a service are becoming important, and cloud platform is in the expansion phase. If you look at the software business model, they're changing the auto software and creating new opportunities. So in the create software, most important phase, again, cyber complexity is adding new challenges and probably increasing the cost of line of software, and better feature usability is needed. In terms of the make software, less important. It really gets a free ride on the hardware, because that's where really they're paying for the software to some extent. Some OEMs, again, want more in-house software, which is challenging. Then if you look at market software, indirect importance, usability, and ease of use is a software create function, but it impacts how well cars are selling. The use software becoming as important as the create phase. Cloud capability advances and pay-per-use growth are coming. In the software strategy at the bottom there, create software, reusable platforms and software ecosystem across models and generation to leverage the create software cost. Make software, reusable software clients give high volume and low unit royalty cost. Extra hardware for future software revenue is a good strategy going forward. In terms of the marketing of software, again, usability, HMI, and ease of learning. The use software phase there, SaaS and cloud bring cost saving and new revenue opportunities. Recurring revenue streams are emerging. So in summary, use phase has mostly been a cost center to OEMs and most other ones, bug fixing, recalls. The use phase is now becoming a profit center in the future. So this looks how important the cloud is, and this is looking at AWS and its impact. It's an AWS, of course, they relies on its cloud computing elements, the infrastructure as a service, platform as a service, and SaaS as well. I'm using my four product categories here, and create, make, and market, and use to illustrate the breadth of AWS products for automotive customers. The green blocks on top there, the list 16 example of AWS's 200 plus services for creating cloud-based products. The AWS has an ecosystem that amplifies the capability with about 10,000 products and lots of experts to speed up the development of software products, especially AI-centric software. The four blue boxes show the product segments where AWS has already worked with automotive companies, and the four red boxes then are examples of how they've used and how are being used by many of the companies. And all of those examples are documented on the AWS website. Note that AWS has its own connected vehicle platform that is used by some OEMs. The AWS connected car solution is a reference design to connect and authenticate vehicles to the AWS cloud. It includes local computing within the vehicles, sophisticated event rules, data processing and storage, analytics, and machine learning. Other cloud providers are, of course, important, and particularly Microsoft, Azure, are doing pretty well in the auto industry. So here's looking at the, I went the wrong way, it looks like here. Yeah, okay. So this one looks at the autonomous vehicle, the software platform. I call them the design win. It is mostly AV platforms for robo-taxi and autonomous trucks, and those are in the red blocks there. I'm using a three-letter code for use cases. So AT is autonomous truck, RT is robo-taxi, and GAV is goods AV. Each block has the design win company in red, and the red lines and arrows indicate design wins to the car. OEMs are in the black boxes. The car OEMs are in the black boxes, sort of towards the top there. Truck OEMs are the blue boxes, and logistics and fleets are the bottom black boxes. It's too hard to draw some of the line to the robotaxi, which are the green boxes there. And then on the right lower, there's a red box that shows other AV platform companies. So overall, I think there are five big five AV software companies: Waymo, Cruise, Aurora, Argo, and Mobileye. NVIDIA is the leading hardware platform for AV, and it has one big software design win, Mercedes-Benz. I also think there are five big Chinese software companies: AutoX, Baidu Apollo, Momenta, Pony AI, and WeRide. I see sort of a big 2+2 autonomous truck software companies, TuSimple and Plus for the AT autonomous truck only. And then Waymo and Aurora are leveraging their software drivers to multiple AVs, including autonomous truck and goods AV. I could spend another 10 minutes on this, because there's so much, but there's no time for that. So let me go to the last slide here. It's the cost and the value perspective, and how things are flowing in the automotive software. So if you look at from the component supplier through the tier 2 and 3 to tier 1s and OEMs, and at each level, I've shown that the software royalty and then apps and system software that are going in at each level, and then going between the various level, I've shown a range of the percentage of the cost or what the next level are paying, what portion software is on that, and of course it's always a range because it varies between high-end and low-end car. And then there's also an estimate of the software development cost at each level, what portion of software, and of course it's increasing as we go along. Then on the right side, our estimate of software cost per auto or per car. And there's one for 2020-ish and one for the 2030 timeframe. So if we look at 2020 first, the bill of material cost is somewhere between $150 and $300 in 2020. The software development cost that you have to use is on the order of $500 to $950. And the car use phase, in terms of recalls, maintenance, is about $150 to $450 per car. And the software has a free ride on hardware, and the cost of that hardware is anywhere from $4,000 to $9,000. Then if we go to 2030, everything has increased quite a lot. So the BOM cost, the bill of materials, about $250 to $500. Software development costs, of course, have increased $900 to $1,500. And the car use phase, $250, $650 for recalls, maintenance, and etc. And again, the software free ride on hardware, now it's $7,000 to $15,000 going forward. And then the use phase has new value opportunity that there's very little of today. And so that we probably can see in somewhere in the order of $2,000 to $5,000 per car for pay-per-use and functional updates. And that's all I have. So